Hello. Today I want to talk about inverse trig functions. Now, hopefully you remember that trig functions take an angle of a right triangle and turn it into a ratio of two of the sides. Right? Any quick Google search will show us what that's going to look like. Sine we'll type in sine function. Sine right triangle. Okay. If we use sine, right, it takes this angle and then it gives us the ratio of the opposite over the hypotenuse. Use cosine, you're going to get the adjacent over the hypotenuse. Tangent, you're going to get the adjacent over the opposite. Now, if you're looking at a different angle, that's going to change where the opposite and the adjacent are. So, going back to where we just were, right? We have three of these that there are three of these that you have likely seen this far in your geometry career. Sine, well, let's say we have our angle, we give that to sine, and that's going to give us the opposite over the hypotenuse. We do cosine, that's going to give us the adjacent over the hypotenuse. Give the angle to tangent, that's going to give us the opposite over the adjacent. So what are inverse trig functions? Right? These are just trig functions here. Right? The question is what do inverse trig functions do? Well, inverse just takes us back in the opposite direction. Now, to be fair, we don't actually usually write sine. We just write sin. We don't usually write cosine. We just write cos. We don't usually write tangent. We just write tan. Now, I'm going to write the opposite over the hypotenuse. And then we want that to go to something's going to change that into the angle. Well, looking back up here, right, we see that sine takes it from the angle to the opposite over the hypotenuse. So we're going to use inverse sine. Now there's a couple different ways this is written. Sometimes it's written arc sine. Sometimes it's written a sine. Most frequently it is written sine to the -1. So if you take the opposite over the hypotenuse and you give it to sine -1, it's going to give you the angle. If you give it the adjacent, if you give the adjacent over the hypotenuse, right? Looking back up here, we see that the adjacent over the hypotenuse is related to cosine. So we're just going to give that to cosine. Inverse, right? Inverse cosine. And that's going to give us our angle. The last one is going to be the same exact thing. We're going to take the opposite over the adjacent. We're going to give that to inverse tangent. And that's going to give us our angle. Okay? Let's actually see an example of this.
Hey, Mommy, you should watch us.
I was watching. It was very fun watching.
Right, so let's say we had a
I was the last one to get
30, 60, 90 triangle. Okay, let's just grab this one right here.
Oh, you got wet.
Nope, not what I wanted to do. Open image in new tab. Okay, copy image. Let's shove that right into here. Paste. Okay, so here's our triangle. Should work for our purposes. Let's first figure out what would sine of 30 be. Right? Well, that would be the opposite, which is 1, over the hypotenuse, which is 2. So it would just be 1/2. Right? So what would the inverse sine of 1/2, right, of 0.5, what would that be? Well, if you think about what we just said, inverse sine just goes the opposite way, right? Here, right, we went from angle to ratio, right? Specifically, we did the opposite over the hypotenuse. Well, down here we took the ratio, remember, opposite over hypotenuse. We turn that into the angle. Right? And what happens if we do cosine of 30? Right? What's that going to look like? Well, it's going to be the adjacent, which is just the square root of 3 right? And then that's going to be over 2. Okay? Again, we're just taking the we're taking the angle right now, and we're taking that angle, we're turning that angle into our ratio. That's what regular trig functions do. They take angles and they turn them into ratios. So let's see what happens if we go in the other direction. Cosine minus 1. Alright, I'm just going to cheat and copy this right here so that we don't have to expend any effort. We're going to put the cosine inverse, and we're just going to shove our ratio into there. And then what's that going to equal? Well, it's going to tell us the angle. Okay? This is all there is to it. There really isn't too much to inverse trig functions. If you're comfortable with trig, right? SOHCAHTOA. You're comfortable with trig. That same SOHCAHTOA works here too, if we're just going in the opposite direction. So let's write that down. Nice big letters. Right, and just remember that this means sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. Let's see if I have enough room to write this on separate lines. I don't think I am. Yeah, I was right. So let's shrinky dinky this just, oh no, let's just delete some crap up here. There we go. Okay. So as long as you're comfortable with this right here, SOHCAHTOA, this half isn't going to feel that crazy. Let's actually do one where we don't know all this information yet. Dump ourselves back down to 12. So not huge. Okay, let's just give ourselves a random triangle. Right triangle. Okay, let's say 72 degrees. Yay, somebody made one for us. Okay, so we'll just copy this one right here. Oh, no, we want side lengths because we're doing inverse. Let's say 8 inches, 5 inches. Nope, that's special right. Special right. Oh, that's Pythagorean theorem. Oh, you know, let's just steal this one anyways. Where'd that Pythagorean theorem one go? Okay. Oh, I hate when I do that. Open image in new tab. We're just going to copy this. We don't even care about the math that they did because it's not really relevant for what we're doing. Right? Now, which angle do we want to figure out? We could figure out the angle that's in between 5 and x, or the angle that's in between x and 10. Let's figure out the one that's between 5 and x. Okay, so we need to label our sides. Since we're looking at the one between 5 and x, the opposite would be 10. The adjacent is going to be 5. Okay, and the hypotenuse, which we don't actually care about, because we only need 2 sides. We can use the hypotenuse if we wanted to. I'm just going to call the hypotenuse x because it's not actually telling us what it is. And now we're just going to solve this. We know the opposite and the adjacent. SOHCAHTOA. So I need the one that uses the opposite and the adjacent because those are the sides that I know. Well, that's tangent. Tangent uses those. But I need inverse tangent. So I need the inverse tangent of the opposite divided by the adjacent. Okay? We're going to pull up our scientific calculator. Make sure we're in degrees. Right now I'm in degrees. Now I'm in radians. Now I'm in gradians. Make sure you're in degrees, whatever calculator you're using. If you do get an answer that's in radians, like you get, or an answer that's in gradients, which we've never used, it's going to show up wrong on the test. Make sure you're in degrees. So I'm going to do the tangent of, well, let's just do the 10 divided by 5 first. 2. And I'm going to take the tangent of that. Tangent of 2. Now the tangent of 2. Oh, whoops. We're doing the inverse tangent. Okay. Let's clear all this crap we just did. Okay, so we need 2, because 10 divided by 5 is 2. Then we need to take the inverse tangent of 2. And we figured that it's 63.43. 63.43 degrees, and that's my missing angle. I'm going to double check this one. I'm going to also figure out the inverse tangent of 5 over 10. Right? Now the inverse tangent of 5 over 10, now I'm saying 5 is my opposite and 10 is my adjacent. Well, 5 is my opposite and 10 is my adjacent. I'm talking about this angle down here. Again, that's just 1/2, right? 5 divided by 10 is 0.5. And we're going to take the inverse tangent of that to see what we get. And we got 26.565, so that's going to round up to 26.57. Right? Now your question for some of you may be, how did this check our answer? Okay. Well, remember the angles in a triangle have to add up to 180 degrees. So we're going to go ahead and add these three numbers, and if we did everything correctly, then this should be exactly 180. 90 plus 63.43 plus 26.57 sorry, equals 180 degrees. So we know that that actually does add up exactly to what we want. So the key takeaway, coming back up to here, you need to remember SOHCAHTOA. You have to know sine, cosine, and tangent. You have to know which two sides they relate to. You have to be able to label your sides. Notice I did inverse tangent twice. The first time I was using this angle up here. The second time I was using this angle down here. After you decide which angle you're looking at, you need to know which side is the opposite, which is the adjacent, which is the hypotenuse. Right? I labeled that before I did this problem. I skipped that step on this problem. Let's go ahead and do that now. My opposite is now 5. My adjacent is now 10. Right? So I did these two, even though I did the exact same work, these numbers flipped spots because the opposite and the adjacent flipped spots because I was looking at two different angles when I was solving it. Okay? That's pretty much all you need to know. So hopefully that helps you get the basic idea of how sine, cosine, and tangent work. And I will talk to you later. Bye.